Thanks for attending this speech. My name is Alexander Fabianich. My claim to fame is the POCO Portable Components open source project. And I kind of built this presentation on looking at all the different solutions for dynamic type behavior within the C++ programming language and what we can do to alleviate that problem. It's really about the abstractions, just like everything else. I was thinking about it last night as I was driving here. I got lost because I was following the GPS, and the GPS took me on a closed road, which cost me about 2 hours of a detour, so I made here very late. But I think, I'm looking at that abstraction as GPS that I can't live without anymore, and I trust it. And then there are people who are worrying about those little details, that device knows everything about where you're going, and they're specializing. And what we're doing is we're on the one side, we're more and more specializing. On the other side, we're more and more using these abstractions. And the logical end is, with this more and more specializing, you know more and more about less and less until you know everything about nothing. So that's pretty much, my take on this. It was a pretty rough road, but let's get to this topic here. People, when they see dynamic C++, think like, what the heck is this about? And of course, it's not about C++ dynamic language. C++ is a statically typed language. It's a strongly typed language with some weaknesses in its type system, which, as we'll see later, can be conveniently utilized and taken advantage of to actually create this dynamic-like behavior. So what this is about, it's about dynamic language like C++ solutions, which we mostly need to interface the diverse data sources and dynamic language environments. And this is mostly interesting in this day and age when we're dealing with various external data sources such as databases or XML files or JSONs. And in the web environment where you have the web pages, you have all kinds of different data types coming at you, and you have to convert back and forth. You have to have a high-level abstraction that is convenient, that performs well, and that allows you to do what you want to do in a quick, efficient, and simple way. So that's what this is about. We're going to look at the existing solutions. So first, we're going to look at the problem, what the problem is. Then we're going to look at the solutions out there. So before we get there, let's kind of enumerate those solutions so we know what we're going to be talking about here. First, we're going to look at good old Bootstrap, who's been around probably, 12, 13 years. Kevin wrote that. It's on the road to be standardized. It's a very simple, very well known. So we're going to look at what's done there. Then we're going to look at the Boost variant, which I've learned people get confused quite a bit which one to use, any or variant. So we're going to clarify that too, and look at some challenges that designers of variant have faced when they were designing the class. Then we're going to look at this newcomer Boost type erasure, which there's something really, really good there, but there's also the interface that is pretty rough. A lot of square brackets, and there are some surprising things if you are not careful what you're doing. So we're going to look at that. Then there's this guy here, the Facebook actually created the Folly library, and there's a dynamic class in there. And Andrei Alexandrescu and Jordan, I can't remember his last name, they were leading this effort. And they basically created something that would allow them to deal with JSON. That's what they do all day long. And they did as efficient as they could. They optimized the GCC to the max. They used all the advanced C++ 11 features. So we're going to look at that a little bit. And last but not least is POCO Dynamic Var. That's my work. That's part of the POCO framework. And we're going to use that as an example. We're going to use some of the facilities from POCO also to put into these classes for benchmark tests, such as converting from numbers to strings and back. And then we're going to run all of them. We look at the results when we run all those conversions from numbers to strings and back and how they perform and compare them. And at the end of the day, we're going to come up with some conclusion of what the current state of the affairs is and where should we go from here. So let's go. First and foremost, this is one of my favorite statements by Bjarne. which says that basically we do need good libraries. And we need lots of good libraries. As Herb said in the last years, going native. That's the area where C++ is suffering the most. And in some cases, you have lots of libraries, but there's a lot of different libraries doing the same thing in a different way, and it's causing this divergent problem, which can be good because we learn, as we'll see today, we learn from it how to do things better, how to do things in a more optimal way. But at the end of the day, you have to come up with a solution that is optimal, make it a standard so that everybody programs against that. And here's another quote that I remember from Robert Pirsig. How many people read Zen and the Art of Motorcycle Maintenance? Only one. It's a good book. It's a good book. There are some pros and cons in there, in my opinion, but it's about quality, really. It's about what is quality. How do you determine what quality is, and how do you make things in a quality way? So he's talking about dynamic and static. Really, in his world, what he is talking about is dynamic is something that is new and unknown, where you're kind of still trying to find your way, and static is already established and you know well. But the quote fit in this context, so I used it. So here's our problem. The problem is that we have these different data types here, the data sources. And they will be databases or just files or some kind of automation or whatever the external data source is. You will face that on a daily basis. There's going to be some data coming out of it. It's going to come in all kinds of different formats, sometimes binary, sometimes it's going to be ASCII. And then you have to serve your destination with whatever they need. So it's going to be some kind of a web interface or an end user or another service running on a server somewhere. So how do we approach this problem? How do we address it? How do we make it easier? First, we're going to take a look at what concerns do we face when we attack this problem. First is, how do we store the value? Obviously, there's going to be all different types of values. There's going to be strings, numbers, custom user data types, and you got to figure out how you're going to store that. There are several options that you can go about doing that. Then we'll want to do some operations on those values. Mostly they're going to be conversions, and mostly you're going to be doing conversions from numbers to strings, but there are also some other conversions that you may want to do, how to go about doing that, and what solutions are out there to help with that. Next is, of course, you want to retrieve that value somehow. How do you detect what's in there? How do you make sure that you retrieve the right thing? You ask for the right thing? How do different solutions approach that problem? Next, there's a runtime performance. Of course, that matters because if you involve too much cycles internally, then you're going to suffer the consequences of it and it won't scale. So you're dealing with the speed, and the other concern is how big is your solution? How much memory do you need to accommodate for all these different types? And what are the ways to go about dealing with that? And last but not least is the code size. How big is the end thing going to be? Because sometimes you'll want your code to be small. If you're dealing with an embedded environment where you're constrained with the memory, then of course you don't want that code to go out of control. Last but not least, there's an ease of use, and this one typically conflicts with the others. If you want to make it easy to use, then you will be suffering on the performance side or maybe on the size. So let's first look at the dynamic data storage strategies. How do different solutions store data internally? First and obvious is on the heap. You just have your void star, and you do new, and this void star is pointing to something, and then it's up to you to figure out at runtime what that something is. So you will suffer allocation overhead. You have to allocate the memory on the heap. And then later, of course, you have to delete that memory. Then there are solutions on the stack, and you can see these little notes here. And basically, the reason why I put notes, these are common ways of naming these solutions, but they're not really completely accurate, because when you say that the value is on the stack, you typically mean that you have internally inside your class some kind of a storage, and then you placement new it there, and if you instantiate that on the stack, it's on the stack. But if you instantiate your wrapper on the heap, then it's not on the stack. But we always call it on the stack, so that's why that node is there. And also about the union here, these typically use unions and placement new, and then unions typically have like a raw storage where you're going to placement new your thing, and then the other member is the alignment, usually where you deal with different platforms and the alignment of this storage. So the concerns here are the size, and then there's also the alignment concern where you have to worry about in some platforms whether you're aligned, and you have to destruct on your own. If you placement new, then you don't get the benefit of automatic destruction. You're responsible to call the destructor. And then there's a hybrid solutions, also known as small object optimization, where you typically look at, okay, let me see how big this thing is at runtime, and then you make a decision which was predefined at the compile time. Are you going to allocate this internally, or are you going to allocate this on the heap? And with that, you will pay the runtime performance penalty, because you have to look at this value that you're trying to put in, how big is it? And based on that, the decision will be made. And then, of course, in the case where you're allocating it on the heap, you will pay the memory allocation price as well. So these are the notes on it. Dynamic data operations support. This is a tricky part. And mainly, how do you duck type this thing? How do you add operations to types? Like dynamic languages kind of can do those things in a language like C++. That's tricky, and Type Erasure does a pretty good job there. We're going to take a look at that solution. So when it comes to the dynamic data operations support, first we're going to be dealing with the type conversions, and you want to, all the time you want to convert from string to number and back and forth, but there are also some custom conversions that you want to do. And these type conversions can be static or dynamic. When I say static, some of these things you can delegate to the compiler. You can basically utilize the conversions that compiler provides you with, like if you are converting from short to int, compiler can take care of that for you. There is also a part that you want to do here at the runtime. If you're doing narrowing conversions, if you really want to be safe, then you probably want to check if that int that you're trying to put into short fits into those 16 bits. And then there are dynamic conversions, which would be take a string, parse it, make a number out of it. Standard language operations, plus, minus, equality, non-equality, less than, and all those other things that we have within the language. And then there are custom operations that you may want to do with your custom types. So let's again review the ingredients we have for this recipe. So we have a placement new and placement new, we have void star, we have union, we have virtual functions, and templates. So all of these solutions that we're going to look at are combination, these things, and they combine them in different ways and provide you with a solution. So let's go. Bootstanding. Bootstanding was introduced, I believe it was 12 or 13 years ago in Boost. It was originally written by Kevlin Henney, and later it was also, there were some contributions by other people. It's a really simple class. This is what you do, where you declare any, and then you assign something. Can be anything, except for array. Can be an array. But you can wrap that char array into a string, so now you're good. And then you can assign it. It has a value semantics. It's well known. We know how it works. People are pretty used to it. And the only downside of any is that it provides half the solution. Because when you want to get that value out of it, then you're facing the same problem that you started with. You have to know what it is. So I love the assignment sign of any. I do not like at all the extraction side of any because it doesn't do any good for me. Now there are some circumstances where it's useful, where basically the sender and the receiver know what they're dealing with, but the middleman doesn't need to know. So you can utilize any in those circumstances, and for example, you can put a bunch of annies in an STL container, and the STL container will happily take them in and hold them without ever worrying about what type is in there. So that's nice. But when you need to retrieve them, then you will face that problem of what's in there. A summary of BoostN is a container for values of any type. It does not attempt conversion between types at all. It will not involve, as a matter of fact, it is stricter on you than the language itself, because if you put in if you put short and you try to get int, it's going to throw on you. So it's not going to allow you to do that. So any type in a single container, it's a generic solution for the first half of the problem. It's a good solution, I like it. And we use any as a basis for the Poco dynamic var, but it addresses the half of the problem. The beauty of it is that syntactic sugar, where you get template kind of behavior without having to have those square brackets. Really looks nice from the syntactical standpoint. So this is how that is achieved. Basically, you have class any, and then what is template is the constructor. So that's how any does the trick of receiving anything, but it doesn't force you to use the square brackets when you're declaring it, which is really nice. So what do things look like under the hood? Here's any, pretty much in a nutshell. There's a little bit more code there, but for the most part, that's it. So what we have here is the constructor we already looked at. Then we have a placeholder here, which is a parent, an abstract parent class for the holder itself. So we can see immediately that we're going to pay two things here in terms of performance, and that's going to be the heap allocation with the new, and then we're going to pay the virtual performance and for the virtual pointer. But altogether, it works pretty well. It's a well-known class. It works pretty well. It's a useful class for what it provides. So here's a use case for any. We can declare a container of any values, and then we can declare, say, a short and the string value, and they can both go to the container, happily live in there. Now when you try to do like this, you can't do this with any. Then if you try to do this, this will throw because the first member is not a string, it's an integer. Now this will work because you're extracting the second member, which is the string. This will work too because you're extracting the short. But then if you try to extract the integer, it won't go. It'll throw you again. In my opinion, that's a pretty significant shortcoming. But any dynamic on the receiving, but static on the giving end. That's pretty much the story of any. We have a generic container for values of different types. It's very simple to understand and use. It's useful when sender and receiver or caller and callee know exactly what to expect, but the middleman doesn't care, doesn't need to know. Receives the values dynamically, but gives them statically, conditionally speaking, not literally. It has the heap allocation overhead, and it has the virtual overhead of performance and size. Everybody good on any? Anybody has any questions? Sure.
On the previous slide where if you had auto A equals the 0 of the container, what type would you end up? Would you end up
Any, yeah.
Class any or
Any.
what?
If you auto A equals any of something, it's going to be any. Auto is just, I mean, auto is just,
But if you use the in cast as an int,
whatever any can, if you any cast to int, then you will end up with int, because that's what it returns. Auto really is, it's a different thing from any. Yeah, auto is just a shortcut for big type name. That's what it is pretty much.
yeah, I was wondering if the actual dot the underlying type.
You'll get exactly whatever that expression returns. No more, no less. Yeah. So,
Wait, you discover the underlying type?
yes, but it's not pretty. We're gonna take a look at it later. There is a type, through type ID. You can see if you're a type ID, you're trying to say if, you ask it for a type. There's a type member, and the type member will give you the type ID for the held value, and then you can say, okay, is this type of ID of int? But it can be, If you need to do that, you probably need to use variant. We'll look at it later.
To me, it seems like the biggest overkill of any is actually the fact that for every type that you're going to use with it, you're going to end up with a separate virtual function table.
Yes. Yeah, that is true.
So if you have to use 100 different types of things, you will have 100 virtual function tables.
Right. Every any has, there's those placeholders hierarchies inside the class itself. So yeah,
Just the
every any has it in.
these end up at especially.
It is, and type erasure avoids that. It just uses straight void and does some other trickery. But there are some conveniences to it. We're going to take a look at it later. The way we've done with the POCO dynamic var, we utilize that because you can make it extensible through that placeholder, so that you can put any user type with all the conversions in there. So it can be utilized for some good things. But you will pay the price. There's no such thing as free lunch. I guess we're learning that over and over again. But we always face the same thing. So everybody good? Any more questions on any? Good. The next candidate is the boost variant. Here's what the authors say about the boost variant. It's a safe boost variant. It's a safe, generic, stack-based, discriminated union container offering a simple solution for manipulating an object from a heterogeneous set of types in a uniform manner. What boost variant is, it's a union of types. That's what it is. Some people like to compare any and variant to void star and union. And to an extent, you can look at it like that, but don't take it too far. They're not exactly like that, but there is some parallel there. The main difference is that with the boost variant, you have to tell it up front what you want it to hold at runtime. If you don't tell it, it can't hold it. So if you want int and string, then you have to declare it as such, and it will hold those types, but only those types and nothing else. The constraint is that the first type must be default constructible. So if you don't assign any value to it at the declaration point, then it will default construct the first type. So the first type has to be default constructible. And it also has this guarantee of being never empty. And that's really a hairy problem. We'll discuss a little bit more about it later. This is how you declare boost variant, integer and string. So it will default construct integer. You're going to have something in there. But then you can assign it a string. It'll happily take that, and it'll give you what you want when you try to stream it out. And you can use the boost get to get the string out of there. And you can do all the things that you could do with the string. So on the extraction side, the variant is similar to any because it will put the same constraint on you that you can only get exactly what you put in there, but it gives you some additional facilities to alleviate that, because you can define visitors that can help with those kinds of things, whereas any only gives you any cast, which is sort of a very simple facility to get your values out there. Visitors are a little bit more advanced, and you can do a little bit more user-friendly things with them. What you have to keep in mind as a programmer when you're using Boost Variant is, what types am I holding inside this object, and what type do I actually have in there right now? So there's still some headaches when you start using Boost Variant. There's some headaches that you have to worry about as you're using it. So for example, you can do something like this. You declare a variant of short and string. You initiate it with a value of 123. But then if you try to do something like this, it's going to throw on you. This, of course, will compile. It will have a compilation error. This will throw because you're trying to get int, but you put in short, so there's no int in there. Very rigid again, similar like any, but you can get the short out that you put in. Visitors. Visitors are a company to Variant, and even the authors, what we've seen on the previous slide, even the authors don't recommend to use Variant like that. If you need to do something more complex with the Variant, you want to use the visitor to really provide the functionality that you need to do. And that's where, in regards to discovering what type is in there, visitors are really nice with Variant, because you can declare, you can define those visitors for the types that you have in there, and then do different things that you want to do with them. We're going to see an example of how to create a visitor for conversion between a number and a string. As we go through this presentation, we do that for pretty much every class but any, and then we will see there's some results of the benchmarks at the end, what that looks like when we run, how do they perform at runtime. So the visitors basically, the Variant supports the compile time check visitation, and the way you do that is like this, that you declare this class is a converter visitor. You inherit from the static visitor of int. If you had an int and a string in there, you will have two visitors, one for int, one for string. And then for integer, you just return the same thing, but if you are trying to convert to a string, then you put a functionality in here to convert to string. This particular class is from POCO, and all the solutions for conversion for this presentation were done with the same class, so that everybody is doing conversion with the same facility, so there is no unfairness there in seeing the results. Behind this, behind the POCO number parser and formatter, we put the double conversion, which is also used by Facebook Foley. Performs well. It's a very good library. What's going to happen at runtime, this visitor will essentially, if you have a string, come in here, it's going to turn that string into an integer and give you the integer out. So that's how you would convert from integer to string using Boost Variant. This is what the code looks like. You declare variant of integer and string, you initiate it with a string, and then you can apply visitor with that converter, and you will get the right thing out of there. So now you will have 123 in here. That's typically how you will go about doing it. There is also a way to do this generically. The previous visitor that we've seen had overloads. We can also do it generically. Say if we just want to double whatever we have in there, then we do this. So whatever you have, whatever supports plus equal will be doubled. If it's a number, it's going to be double the value. If it's a string, it's going to be double the string. Not sure how useful that is, but in cases it might be a valid approach. Makes things somewhat simpler. So that's what it would look like. That's what you would get.
Why do you have two eggs and
You would really have to have one for each type that you're holding in here.
You already say the return type of consent.
Oh, you just do it. You just do it in here. So whatever operand you pass in here, but the thing is that what you pass in here, you will have to have a visitor because this thing can hold either a string or an int. So you will have to have a visitor for each one of those. What you're saying is, why don't you have void in here? Perhaps. I'm sorry?
why do we have to have int?
Usually the return type, you can override the set of the void and write the return type.
You could. Yeah, you could have, if you wanted to have a return type, then you would want to have this. But if you don't,
But
you
you can write return type, find the set of the type that takes the type in and defines return type or result type. I don't know exactly. You can use this to always be sure to use the correct return type in the operator.
yeah. This is what the default construction for Boost variant looks like. Basically, what variant constructor does, it placement allocates in the storage on the stack, as we discussed before. There is a sort of work in progress on doing it on the heap, and then there are some also complications with the never empty guarantee. But the default implementation is basically it's a placement new in the local storage, and then there's an indicate which basically tells you what you currently hold inside the variant. The constructor looks like this. So there's a convert construct with this dummy value here that is not used. So you pass the operand in there, and this is a flag that basically tells you whether you're doing this from just a user type or base type, or are you doing it from another variant. And then you indicate which, and then you initialize with the storage address and the operand. There's really two things there. There's that, I think that's on the next slide. That's what the storage looks like. So you have that which, two things. Which tells you which type you're holding in there. And then there is a storage itself, which is basically a storage T type. And the storage T type is a union of a buffer, which is the raw memory where you will construct your type that you're holding in there, and then there's an alignment. The address will basically just give you the address of your internally held type. The challenge that the designers of Variant faced with the never empty was I really wasn't part of the Variant design, and I'm not really an expert on the Variant. I just read through the code and I looked at the mailing list and what they faced and talked to some people that were involved there. But it's really about how do you deal with if you're constructing from another variant, if you're copy constructing from another variant, what if thing throws? How do you get back to the valid state? So there was different ideas thrown there, and variant actually, the documentation states that it might allocate on the heap in such cases. So there might be in the background, it might allocate on the heap some storage to keep the old value there until it makes sure that the new one was actually constructed without an exception, and then it's going to get rid of the old value. Yes?
Side question, why is that not in
The question is about the alignment. Why is the alignment needed in the struct? In theory, yes. In practice, when you go to different platforms, no. Yeah, go ahead.
It's needed because if you don't have the alignment, then it will only align to, it may only align to the size of the chair, which is one. And if you have something that requires a larger alignment, then
So,
that, then it's not, then it may be, then you may do this wrong.
are you saying that it won't take the size into account?
Not necessarily. It's not guaranteed to be.
I guess then that's even more accurate answer, that the size is not necessarily taken into account. The alignment will be just for the chart. You will see the alignment in all the solutions that are out there in production. You will see the alignment in the structs like this. They're always there. And it's even been, there's this STD align in C++ 11. So it's always, it has remained a concern. The boost variant summary is strongly typed, kind of similar like any, except that the number of the set of the types that you can hold in there is limited. It's more complex than any, but it also provides some more advanced facilities to do various operations on the values inside the class. Default, it's on the stack, i.e. internally, but it can also be configured to allocate on the heap. It's a compile time switch, but it doesn't come like that by default. There is no built-in data conversion. You have to provide that as an external facility. And then there's that implementation complexity due to never empty guarantee. I kind of thought about that, and I was thinking, why this never empty? But if you don't have never empty, then you always have to worry about empty when you're doing your visitors. So that's kind of a downside of it. Personally, I'll kind of go with empty. If we just make it empty, because the example that we've seen before, where you have, say, variant of int and string, the default construction of int is meaningless. So you might as well have an empty there. But yeah, go ahead. Yes, that was proposed in different conversations that I've seen on the mailing lists, but then you do have to worry about that empty when you're doing your visitors, because there's one implied type always in there. So if you have int string, then you also have to worry when you're doing visitors, you also have to worry about the empty, because the empty is always in there. So that's the downside of it. I don't personally see it as a big problem. I would prefer, because the complications otherwise are just big, complex. Yes.
Inherit from the static visitor and simply provide one implementation for the end case and
Right. That might be also an idea where it was proposed that you can inherit from static visitor, and that parent class would always have the empty case. That could be one of the solutions. Again, I'm really not a top-notch expert on variant. I didn't design the class. I used it to do some benchmark tests. So there's been a lot of conversation about it. There's been some proposals to standardize variant. Some people don't like any. They want the standard variant. Some people don't like variant because it's complicated, because of the never empty guarantee. There's conversations going around. I think both solutions have their ups and downs. There's always a trade-off. The visitors perform reasonably fast, and implementation employs all known means. This is according to the authors. All known means to minimize the size of variant objects, often unsuccessful due to alignment issues and potentially harmful to runtime speeds, so not enabled by default, as we mentioned before. Here's the question that was asked before. if you find yourself doing something like this, in my opinion, then you should use variant, not any. If you're trying to discover what type you have and you have many types in there and you have this kind of logic, then you're probably better off with the variant. Before we go further, any questions on variant? Any comments? Everybody good with it? Yeah.
One question.
Sure.
Is the variant class actually face the same problems with C++ web with in terms of the never empty guarantee?
I guess the question is, does the variant class have the same problem with the C++ and never empty guarantee? And the answer is yes, is the best I can tell. Now, there is somebody who knows quite a bit about variant.
It has the same problems, it's just there are a few more tricks we can use to get around it because we have move as well.
Right. Yeah. But it's
But
pretty much
the
the same.
problem still can't.
Yeah, the problem is still there because you have that. You have this, and you want to replace it with something else that has to be constructed here. And if this throws, then you have to be able to go back to something that's good.
That seems like a move for now.
Well, it does help, yes, but does it really solve the problem? I don't think so.
So when you have a node for a move, then it's safe.
Yes.
But so as long as you have a node for a move and you can detect the fact that you have a node for a move, you're okay.
Right. In some cases, but that's true. That's true with some other.
Yeah.
You know, that was true before when you only have a move with some other types that you know they don't throw. So you have a type that won't throw on construction, then you don't have to worry about
So
it.
you need to annotate all the types with no throws.
Yeah. Good luck with that. Okay. Next, boost type erasure. This is a newcomer. On this one, I'm even less the expert, but I did study a little bit. It's an interesting solution. I like some aspects of it. It's also complex, and it is my opinion that another layer of abstraction on top of it will be really nice, and it will give some much needed interface easing in that sense. So what boost type erasure does, it generalizes boost any and boost functions. So with boost any, you can put any value in there, and then the boost function, you can kind of attach operations to it. So if you think of a dynamic language like behavior, you have two aspects there. You have different values that you can hold inside some entity, and then there are different operations that you can do on it. And that's where boost type erasure comes to help you if you're trying to do something like that. Personally, to me, the name is confusing, and it's really what you think of as a type. To me, type is more associated with the value, and then the operations that you do on the type are not part of the type, but that's a whole other can of worms. But here's a list of the proposed alternatives of the names when the type erasure was discussed for introduction in Boost. Stage typing, deferred typing, type interface, interface, static interface, value interface, structural typing, duck typing, and runtime concepts. I don't know. I'm not sure which one would be which one would be the best. Type erasure to me is a little bit. When I think of type erasure, I would think of any. Just erases the type. So once you put thing into any, the type is erased. You can use it without regards to the type. Shuttle it around. The type erasure does more than just type erasure. That's my opinion on it. It addresses the limitations of virtual functions, their intrusiveness, the dynamic memory management, and the limited ability to apply multiple independent concepts to a single object. Those are the goals that type erasure is aiming to alleviate. What it looks like is this. You can see there's quite a bit of, compared to any, I'm not happy with this syntax. It does pretty much the same thing. You put anything in there, and then here basically you have this vector of concepts. So you can put that in and have any value, and then you can cast it out just like you would do with any. It's very, very similar. Now feel free to interrupt me if you want. I see you smiling, so if you have any comments, don't worry about interrupting. So how does type erasure add operations to that any type? Something like this. You add all these things that you want your any to be capable of, so you can make sure that it's copy constructible. It's type ID, it's incremental, so you can do plus plus on it. All streamable, you can stream it. And then here's your x, and then you can do this. So you give it 10 plus plus x, you get 11 out. That's pretty straightforward, right? But let's say that you want to do something a little bit more complicated, and you make it addable. Don't need it. You just can add. So you have this any type, and then you declare any type of a double, and another any type of an int, and then you add them. And here's $1 million question. What does this print? Anybody knows the answer? Nobody? Come on. Let me help you. Let me help you here. Whatever you say, you can go wrong. That makes it a whole lot easier, right? I mean, this is about, dynamic.
We'll throw in the plus.
You would hope that it would, yes. That was my take on it. That was my take on it. Unfortunately, no. It's an undefined behavior. So that's where I'm coming from when I say we need another. There's another layer that needs to be on top of it, shielding mere mortals from these kind of things, because an innocent average C++ user would do this. This is the first thing you want to do. That's the first thing I want to do. Okay, let me see. And there's a way around it. But even the way around it, I'm not happy about this name because it's called relaxed match, where it should be a strict match, really. If you add relaxed match concept, then it will be more strict in allowing you what you can do with it. Now, can you maybe explain why it's called relaxed match? Because I couldn't quite get it.
Well, actually, I changed the name to Relax.
Oh, you I'm sorry, say again?
I changed it to just Relax.
Oh, really?
Yeah. Anyway, the idea is it becomes, when you add that, it adds extra checking so that you can get away with more, basically.
Now you must be the author of that.
Yes.
Oh, okay. Now that's good, because you certainly know more about this thing than I do. Okay. And this is by no means to bad. It's a good thing, but it needs a little bit of something to shield people from troubles like this. Now you make me nervous. So what we can do is basically wrap that properly into placeholders and do the right thing and get what we want out of it. So we declare double and int, and then we put these requirements in here with the placeholders appropriately, so you can copy construct them and add them, and then you make a tuple of those, and then you get your types out of it, and you add them, and it'll do the right thing. So my point is all this should be kind of something behind a nicer interface. That's the way I'm looking at it. And then also you will have the same problem if you try to do something like this. Go ahead.
So, I guess I'm missing something here. Where is it that in here?
He's probably better source than I am.
I'm
happens is in that type def, you can think of the underscore A and underscore B as the acting like template parameters. Okay. Then when you create the tuple, it matches underscore A to the first argument, which is the double, and underscore B to the second argument, which is int.
Okay.
How to do the conversion with the type erasure? Provide a similar facility like we did with the variant. What you want to do is something like this. You want to have an integer and then construct any from that integer and then be able to do something like this. Turn that into a string. First, what you do in achieving that goal is basically you declare this toString struct with templated on the from and to type that you want to convert. And then you have this magic apply function in there that takes those from and to and turns from into to and then returns it. The other part of this scaffolding is basically a binding. We have this concept interface and you put that toString struct in there and then you rebind that and you have this toString in here that will do the basically just delegate that conversion to the original one. The way to use that thing is like this. So you say type def any of toString, and you call that stringable. You declare an integer, you declare a stringable from that integer, and then you call toString and you get the right thing. So this will actually do the right thing. This will put 1, 2, 3 into your string. Any critique on the approach?
That's basically how it's. Can you go back a couple slides?
Sure. This one?
Yeah. I just wanted to point out that since this is a really common mistake, you have a dry graph in the def. That's what I think.
Oh, okay. Good catch. Good catch. Thanks. I must have picked it up from somewhere. Yeah. But good catch. Thanks.
It's a really easy thing to do.
Obviously. Yeah, I'll fix that on the slides. Thanks. The storage. As you can see here, there's basically just the void pointer, and then the type is it goes directly into that void pointer. So, and type erasure performs pretty good, I have to say, on the benchmark. It did pretty well. The binding of the concept of the actual type, basically through the binding template, and then there's an actual storage in data, and then there's a table type, which essentially the table type basically holds your concepts, right? If I remember correctly.
It's basically the same as the VTIP.
Right. Just static, right? So that's the really contribution of the type erasure, that it alleviates those virtual calls that you can get with the virtual hierarchies. The summary, the type erasure extends any invariant or variant by introducing a mechanism for attaching operation to types at compile time. Very, very useful facility. Very, very useful functionality. I like it a lot. It addresses the limitation of virtual functions. It does use heap allocation to store values. It's a pretty complex thing. And if you're, it's really, right now at this point, it's pretty much for experts. I don't think an average C++ user should get involved with doing much with it. Would you agree, or do you think that that's not accurate?
Basically, the way I intended it to be used is you make a few type tests up front for the things you're going to do.
Right, right.
Because getting all that set up, no matter how you do it, is going to be complicated.
And that's exactly what I'm saying. When I say an interface, I'm not saying that you have to come up with the whole library, but perhaps, you know, the type defs or constructs similar to the toString that, you know, I showed before, and things like that that people commonly use that will be really safe for an average user to just take and use.
Yeah. So adding more common cases.
Right, right. There are some slippery scenarios. And here's my comment on another layer of abstraction. Everybody good on type erasure? Okay. Still have time. So next step is the Facebook Foley dynamic. Now before we go here, okay, let me see. Pretty much probably everybody here is a Boost user, I would assume, but can I see some raise of hands? Boost users? Okay. All right. Does anybody use Poco here? Wow. I had more users than that at ACCU. Now, does anybody use Facebook Foley? Anybody who never heard of Foley? Wow. Okay, so I'm doing some. Anybody never heard of Poco? Well, no, before this. Okay. All right. Just to gauge a little bit the audience. Foley dynamic is a runtime dynamically typed value for C++. It's similar to the way languages with runtime type systems work. That's from the authors. It'll hold types from a predefined set of types, so it won't hold anything. There's a union there with the, you know, int double and all those things. It supports objects and arrays because JSON was their motivation, so they have those dynamic object and array types. It's union-based, somewhat reminiscent of Boost variant, sort of similar to it. It has runtime operation checking, so you're pretty safe into when you do things that the engine behind it will check what you're doing. It's Linux only. It is heavily GCC optimized. Uses anything they can use from C++11, and the build is a nightmare. I told Andre it took me 4 hours to build a doggone thing. It should be better than that, and they acknowledged it. There's a lot of little dependencies, and once you build it, it works. But it's just not easy. The way it works, and I only tried on Ubuntu and Fedora. I don't know about other Linux distributions, but I would assume it's similar. They have some packages that make it easier here, but some things you just have to go and grab yourself. What you do with the dynamic is something like this. 12 equals 12, so now it's holding an int, and then you can have string, which is not standard string, it's a Facebook string, which is compatible with standard string, except that you can't assign Facebook string to a standard string. There's a support for null pointer, Boolean, all those good things that you will see in a dynamic sort of language. Once you build it, it's good. I like it. I just hate the build process. It has a clean, intuitive, and reasonably predictable interface. I would say it's very user-friendly. If you're C++ newbie or average user, you won't end up in trouble with Foley dynamic. You can do things like that. String of 1, 2, 3, and then you can do var of string. Then you can get it out as int. You can get it out as double. Then you can assign it an int. Then you can get it out as string, but if you want to assign it to standard string, then you have to go back to C string. This is a Facebook string. So Facebook string, because it's compatible with a standard string, you can do this. But you can't directly assign it because standard string doesn't know how to assign the Facebook string.
So it will throw if cannot perform the numeric conversion.
It will throw, yes. I believe it will throw. I'll have to check. I believe it will throw. I'm kind of almost safe, almost sure.
So, in this case, it's not, I mean, you declared str as std string, and you're saying that it's making underlying storage Facebook string, even though you...
Yes. Yep. You can assign a standard string to a Facebook string. You just can't go the other way around because the standard string doesn't have the constructor for it.
Yeah, well, I'm just, it's kind of well, maybe you're going to get into the internal, but it's surprising that it would take on the type that you're putting in.
Which one exactly you're referring
So
to?
the first line there is std string, right? Then you
Yes.
assign it to var,
Yes.
but somehow it's reducing and making it a Facebook string.
Yes, yes. The reason why they did the Facebook, and I'm not speaking for them, and I didn't really investigate too much, but it has to do with the performance. They've done something with probably, I would think, some sort of small object optimization or something that makes it perform better. I mean, they have billion users. I'm sure they have good reasons to make it perform. So. And you can do also this. It's a similar thing like one here. Behind the scenes, it's somewhat similar to the Boost variant. This is what the storage looks like. So it's basically a union of predefined types. And here's the alignment again. So we can have in there is the null, array, boolean, double, integer, and string. The way how you get the stored type out of the dynamic is basically, for example, if you look at that as string, it will give you the Facebook string. Obviously, as impl that they're using here is this template function. So it's going to look into what it is and then do the right thing. They try to get no throw. So the answer to the question is you're going to get null, not you won't throw. You're going to get null if you can't do it. Let me see. Okay, let's take a look at it. And the get no throw here is going to compare the type, and if the type is no good, it's going to return the null pointer. So you're going to get the null if you can convert. You won't throw. It will be a dynamic that's holding a null. You try to do the conversion, and if it doesn't go, you're going to get back the dynamic that's holding a null. That's opposite to like what we do in Poco. We throw. If we can't convert, we throw.
Can you go one slide back?
Sure.
Two functions over there.
Which one?
There's a function.
Yeah, we're gonna get to that. Those are the
Not
two.
throw them.
Those are the functions that are in the two header. I don't think that's throw no. But I would really have to check. You can return. You can return it. Oh, you're asking if you're. So were you asking if you're assigning to a dynamic or if you're assigning to just a plain old type?
I wasn't even concerned about assignment, just in terms of extracting it, if that gives a bad cast or if it's the wrong type.
Yeah, I will have to take a look for that case. If you are converting to I'll have to take a look into in the two functions exactly what they do. The two functions they use double conversion. I know that, but if he can't do it, he may throw there. He may throw. Yeah. So this is what the get no throw looks like. It calls the get address, and then the get address calls the get data, and the get data basically calls. See, it will give you the it will give you the member that's in there, but that member might not be good if you have something else. So basically, this is where you shield yourself from that you don't end up retrieving something that is no good. If you're holding a bool and trying to retrieve an integer. The conversion is actually in the two functions, and it was just too big to put it here. It was written by Andrei, and I had to take a look exactly how those functions behave. I'm not 100% sure, but I do believe they do throw. In the behind the scenes, it's using the V8 double conversion. It supports arrays and objects, so you can do things like iteration, and you can do things that it's kind of similar like what you would do with the JSON.
Can you explain what V8 double conversion is?
V8 double conversion is part of the V8 is the JavaScript engine in Chrome. The double conversion is the library that is inside the V8, but is also available. It's a Google library. It's also available as a separate library for conversion to numeric, to and from numeric types. So it's basically, it's that hairy problem of if you convert doubles and you end up in, you have 2.0, but you end up with 1.99999. You can look it up. It's freely available. It's Google open source library on the Google Code. We also use it behind the Poco dynamic conversion classes. The summary of the Foley dynamic is that it's built around Facebook's JSON's needs. It uses C++11. It also uses Boost extensively. It performs very well, and in my opinion, has a really good design performance balance, where you get these nice interface, but it also performs well. User-friendly interface. It is not portable, and that's probably the biggest downside for that class, that it's Linux only. It's holding only predefined types. It's hard to build. Sure. The question was whether Foley Dynamic is Linux specific because of the Linux operating system or the GCC and its support for the C++11. I really am not qualified to answer that, to be honest with you, but
I can answer that. I think it has more to do with the C++11 support than C++. Because I backported Foley Dynamic to a Linux C++11 by just cutting out all the variables and doing stuff in the design. But it's basically the C++, or that part of C++.
it might. I think what it supports I would think that the guys at the Facebook, they do what makes sense for their business. They run their business on Linux with GCC, and that's what they do. That would be my take on it. But again, I'm not speaking for that. I'm just presenting on what they've done.
And then second question, how easy is like standalone? How easy is how can we add it? Does it drag in a lot of other Facebook classes like the string and exceptions and also some titles for the?
I believe the Facebook string is dragged in.
Yeah, so it's dragged in Facebook string. They also got a thing called conversion, which uses a bunch of stuff that it drags in. So I'm not sure it's dragged in that way. They have their own thing.
Right. So the question was how difficult it is to use as a standalone class, and the answer is that there are some Foley classes that are dragged into the dynamic. I'm not really sure. For a fact, we know it's Facebook string, perhaps Facebook vector, how many other things. I had to build the whole Foley in order to run this. So The license is Apache, I believe. The license is Apache. And from what I'm seeing is Facebook will drive this in the direction where they want it to go, and if there is enough interest to port it to other platforms, they'll probably be happy to see that, but I don't see a lot of effort from them to make that happen so far. And it's been out for probably a year, I believe, since they open sourced that. So. Next, Poco Dynamic Var used to be called Dynamic Any. We put in the separate namespace. It's based on Boost Any pretty much. So what you will see in there is Boost Any foundation, and then that extraction side is elaborated on, so you can do things like similar to what you've seen with the Foley dynamic. It aims to be a general purpose dynamic typing facility. It balances between performance and ease of use. It provides transparent conversion, and my beef is just the STD string where I can't assign my var to STD string, because depending on not only on the compiler but on the compiler version, your STD string will be confused whether to take it as a STD string or a char star. And really then you have to do two string, then it's going to do the right thing. Trying to typecast it, I played a lot, and it just, you're safer to do it as string. Everything else is kind of, you can assign things to each other. And we'll see later examples in the code. The conversion is checked, so if you try to convert, say, an integer to a short, and this is bigger than what will fit into a short, it will throw. So it will use the compiler facility to convert it, but if it's too big at the runtime, it's going to prevent that from happening. And then it has the capability to hold any type, and it is extensible for user-defined types through holder specialization. So it's basically pretty much the holder that you've seen in any, but it's been elaborated on a little bit so that you can provide your own types and your own conversions for those types. There is an optional small object optimization, but it's still very much a work in progress. It's not coming with the releases by default, so we're not quite there yet. The tests that I've done, I have not seen a whole lot of improvement with it. More on 32-bit than 64-bit, so I just had to find a little more time to work more on it. Here's what it looks like under the hood. You will see immediately that it's reminiscent of that any class. And what basically you can see is that it does the same thing here. So you have that syntax sugar, and you have that holder that's essentially holding any value. And the holder is elaborated on a little bit. So here we have the parent class, and then we have the intermediate sort of for end user extensions, and then all the built-in and most frequent types such as ints, doubles, std string, and some common classes that we have like datetime and things, and tuples. We provide basically the holders for those, so you don't have to worry if you're doing things with them, they will be there. But if you have your own type that you want to hold inside the dynamic var, and you want to define, you want to specialize the holder for it, you can do that. It's open for extension. The conversion, this is an example of conversion to smaller unsigned, so it's going to do the checks and see if everything's good here, and at compile time, and then at the runtime, it's going to check for the upper limit to make sure that you're not to do something that you're not supposed to do, and then, and only then, it will do the thing. Of course, there's a price to pay for it. You shield the user from the danger, but then you pay the price on the back end. This is what the to and from string conversion looks like. So it inherits from the var holder, and the conversion, basically this is specialization for string conversion to short, is that same old number parser, uses V8 double conversion just like Facebook Foley, and then it will convert to smaller. conversion to double, an example here. So if you go from string to double, it'll do number formatter, and it's going to format that into a double. This is to and from number, similar thing, 16-bit integer to 32-bit, check for smaller, 32-bit to unsigned 32-bit to signed 32-bit. Again, it will check for conversion. So it does shield the user from all the potential perils that they may get involved with. And then there's extract, which is basically an equivalent of any cast. If you know what's in there, you can just get it out there and not go through all the discovery. So you just, hey, I know what's in there, just extract this type, you get that exact type, gain some performance. There are some checks done, of course. It'll check if your types if it's really the type that you're trying to get out of there. But this pretty much performs the same as the Anycast. That's what this is. This is what it looks like in practical use. So essentially, you do string and then assign that string to var, and then you can assign that to an int. Then you can assign that int to var. You can increment it, and you can see the value will change. You can assign it to a double. Then you can add just another double, have a float. It'll do the right thing. It looks and feels like a sort of dynamic language. There is also a dynamic struct similar to Foley object, where you can do things like this. Here's what I was talking about before. If you are constructing a string, then you have to explicitly say toString. The other way around, you can assign toString to a var without any kind of conversion, but here you have to say toString. So that's the only kind of thing that I don't like, but it's not that big of a deal. If you want a little bit more performance, you can template your struct on a pod. So you have keys here as integers. You can have basically the vectors of vars, and then similar like what you would do with any. And then also, if you put the vector inside the var, it will behave like an array. So you will be able to do all the things that you do with an array. A lot of stuff going behind the scenes. You will pay the price if you try to do that. When you do this, it will, like if you do struct to string, or if you do array to string, it will give you JSON out of it. So that's built in. These are the results, and this was several years ago when I published an article in the ACC Overload and compared some sizes of the binaries that you get. So you can see, for example, the code of any and the code of dynamic any at the time. So there's quite a bit of size price that you will pay for this functionality. That code is big. There's a lot of stuff going on in there. So that's pretty much the downside of this approach. And then there's also the performance penalty that you will pay for all those conversions in the background. In some cases, it works well. In some other cases where you really need to squeeze every bit of performance out of it, you probably will not opt for that. And that's the same thing that the Foley dynamic people tell you. You know, sometimes it's very useful, but sometimes you just can't resort to that kind of a functionality. The benchmarks are pretty much along these lines for all these classes. So essentially what we did is create a string, then put that string into some holder, then assign that string to an integer, then assign that integer, and then assign the string to a double, then assign integer back to the var, and then assign the var to string, and then double to var, and then again string back from var into a string. This is pretty much what we've done with boost variant, type erasure, Foley dynamic, and Poco dynamic var. And the results are here. So type erasure, obviously the winner here. Foley dynamic, pretty good. And then var and variant was faster than var. Now one surprising thing when I was doing this I couldn't run dynamic on Windows, but I was really curious about how, because there's a C# dynamic. So I was curious, how does C++ compare to C#? I had to say that C# was faster than C++. And I put all the optimization on Windows. But then I took these 3 classes that I was able to run on Windows, and it was run on the virtual machine running on the same physical machine, and they were 4 times faster on Linux. So that's kind of just a rough idea. There's something, I really don't have a firm proof or anything. I can just tell you that these classes will perform much slower on Windows than they do on Linux for some reason. Something to do a little bit of research on why is that the case. And here's an overview of the features comparison. So if you look at any, you can assign all types to it. It doesn't provide really any operations on those types other than getting the same type out. Doesn't provide any conversions, and the retrieval of the value is externalized, not part of the class. Variant, you can assign predefined types. Operations are external through visitors mainly. There's no built-in conversion, and then the retrieval of the value is also with the external facilities. Type erasure, you can assign anything to it. Operations are sort of internalized, at least they appear such. There is no built-in conversion. Retrieval is also externalized. Dynamic has predefined types. Operations are built in, they're internal. Conversion, just the predefined conversions, and then the retrieval, there's an interface of the class that gives facilities for retrieval of the value. Dynamic var will take any value, it has internal operations. Conversion is basically the specializations of conversions for types. So it's sort of built in. Retrieval is pretty much automatic. There are casts happening in there where you can assign things to each other, as you've seen before. This was done by Schalk at the ACCU. It was kind of at a glance of the presentation. He put everything that I was talking about, kind of, so put it here to share with you. Now here's what Herb said. The biggest problem facing us is the lack of large set of the Euro and de facto standard libraries, and I do believe that that's a problem for C++. And that will be my presentation. We have 3 minutes for questions. Yes?
Yeah, I know Spirit has a old any where the storage model is similar to type erasure, but they have small object optimization. Does type erasure have that as well?
The question is about the Spirit's facilities for type erasure, and I believe that Steven is probably more qualified to answer that than myself.
Okay, so I don't have a small object optimization yet. I tried to design it so I could add it in the future. But I didn't want to get too far into optimizations before I had everything else nailed down. So I'm the guy who writes the Spirit view tree and who works on the Holden stuff, which is the Spirit separation stuff. And it's very designed specifically for Spirit. The small object optimization may or may not be really important in the general case. We have very specific design requirements for those constructs. And those design requirements of, human parser thing. So it really can be used for that. And also there's a lot of things that can do there that are kind of nowadays say portable or general case.
Yes. It is. It is to an extent. Yes. Yes.
But the whole idea of strong typing is that they give you some really positive features that students use. And why not use the strong typing when you do come to so you can self-describe recipes. I've gone through this in the system, and I tried using it, and it was a real pain.
Yes. I'm really interested in what Steven has done. That's really interesting because what we have in like Poco Dynamic var is essentially just holding any value and conversion that are most common. But then how do you add custom operations on types and things like that? That's very interesting to me. And based on your so your question was, do we look? Are we playing?
It's almost with partly rhetorical, partly they're always addressing, but partly also should we really be looking at self-describing this, sort of extending from ideas of code, going the other way.
I mean, the question is, should we be looking at the self-describing messaging? Does that? I'm not really familiar with that concept. So is that like changing the language, or will it be a library solution?
Basically, library solution. Generally, this is a very common problem in distributed systems where you have sources, different ticker sources and the like, and you want to sort of homogenize them, but still retain their
Yeah.
types on the like.
I think of like if you put something into a JSON and send it across, it's sort of self-describing, but you may not want to pay the price. There's always this balance of, if you want to be fully, static and performant, then you will pay the price on the user interface because user will have to worry about things like you mentioned, with Annie. So it's always like that. This, indeed, my work with Poco Dynamic var, yes, it is kind of taking into a direction of a dynamic language, but it's still static. I mean, C++ is a static language. You just use those holes into the type system that allow you to provide dynamic-like behavior, and it really works nice in many circumstances. I have another presentation at 11 that actually shows that in the practical use, how can you transparently just get anything from the database and things like that. So we can take that conversation there if you're interested. I had to find out in which room I'm speaking. It's kind of a challenge, to find your way through the maze. But yes, so there's a whole other 90-minute presentation that's talking about, pretty much it's about the Poco Dynamic var and the use in real-world scenarios, like when you're querying the database, or if you want to take, say, event-based insert or update in the database and reflect it on the web page without, really having to do it. It just kind of goes. It's event-based. So that's the next speech. We can take it there and discuss it further. Yes. Poco Dynamic var supports JSON in a very. It's a question. How much does Poco Dynamic var support JSON? Does it support the JSON arrays and objects? Right? Is that where you? It will parse it. Let me put it this way: the JSON support within Poco Dynamic var is very rudimentary, but we have a JSON library, which uses dynamic var extensively. So that's where we kind of put focus on JSON. So, yes. Yes. The question was, what would it look like in terms of performance if the JavaScript interface was kind of wrapped into a similar functionality? With regards to Poco, what we're doing, I started the works a couple of years ago, but then it got stalled, and then there were some other contributors that have done some work. I started work on a script library that will have a front end, and then you could have different scripting backends. So that was the approach that I was deeming appropriate for addressing the interface toward the dynamic environments. Now, how would JavaScript API compare to this? I really don't have an answer, but it will be an interesting, topic for research. Yes, yes, and double conversion is coming straight from V8 JavaScript engine, so they're using the same thing. That's pretty much what it is. Mostly what you're doing is you're going between numbers and strings. That's what you're doing the most, and that's what that thing does, and it does it pretty well. So, any other questions? Well, thank you very much. Hopefully you enjoyed it.